So in part B1, we need to show that the x-coordinates of P and Q satisfy this equation. So the way we can find the x-coordinates is that we know at P and Q the derivative is equal to 0. So if we know that, we have found in part A the derivative of this function already, so we just need to set the numerator equal to 0 and solve for x. So let's do that. So we know 2x minus e to the x plus y has to be 0 for the x-intercept. And then we need to start solving for x here. So we know 2x is equal to e to the x plus y. We can take the natural log of both sides, so we'll have ln 2x is equal to x plus y. And well, from this we can see that y is equal to x minus, no, so y is equal to ln 2x minus x, like this. And we know from the original formula in the question that there's this formula for y. So we see that in this expression there is no coordinates of y here, so we need to do some more substitutions. So we can plug this value of y into the original question that was given. So what we'll have is e to the x plus ln 2x minus x being equal to x squared plus ln 2x minus x squared. So what we have here is ln e to the ln 2x. This will be equal to x squared plus, and then we have to expand this out, so ln squared 2x minus 2x ln 2x plus x squared. And then we know that this term will simply be 2x, as e to the ln something is just that something. So we have 2x over here. And well, this is still equal to the same term. We can combine these x squared terms. So we have 2x squared plus ln squared 2x minus 2x ln 2x. And then we just need to subtract this 2x to the other side, and then we'll have the equation that we need. So we have 0 is equal to 2x squared plus ln squared 2x minus 2x ln 2x minus 2x. Alright, so that was part 1. And then in part 2, what we need to do is find the coordinates of P and Q. So if you remember at the start of the question, we were told that these are where the tangent line has a slope of 0. So we just need to find the points that satisfy this equation. So we can do that with our calculator. We can simply plug this expression into our calculator. So if we do that, we can go into nsolve. So algebra numerical solve, and then we can plug this equation in. So we have 2x squared plus ln squared, and here we have 2x minus 2x ln 2x minus 2x, and we want to solve, and this is equal to 0, and we want to solve for x. So I have a missing brackets. Let's write the squared over here. Yes. So it's important here to note that whenever we write an ln x, or if we just write a function like sine of x, we always want to include a multiplier here, because the calculator will not be able to understand like x ln x. We need to specify that there's a multiplication in between this x and ln, and same over here. So we need to write the square as the whole term. When I wrote it here, it didn't accept it. So we know that the first coordinate will be 0.333. And then what we need to do now is plug this 0.333 back into this formula to find the y coordinate, which will be 0.743. And then we can find the other point as well now. If we go back to our calculator, we can copy this. If we paste it, we can find another point. If we set the domain to be like from 0.5 to like 2, maybe let's say 5, like this, then we will find another point which is just above, so we can look at the graph again. Q is a little bit further. So here x is equal to 1.84. And again, we can plug it into the formula for y. Together, the y coordinate is minus 0.538. So these are the coordinates of P, and these are the coordinates of Q.